Hey students, so glad to have seen all of you a few days ago. We are beginning our lessons in science, in earth science, continue where we left off in March. Before we get to the lesson, I have a few announcements. We do have assignments available for you in the assignments tab of your team's application or your team's profile. After we have this lesson, you can take the time to review those lessons. This is a pre-recorded video, so you'll be able to go back to it as a resource to answer some of those assignments that you have. If you need to take the time to get some paper and a pencil or a pen, you will need it as you go through this lesson today. If you have any problems with working out some of those worksheets, feel free to email me, or you can use the homework hotline. That information is supplied to you in various emails that we've sent. You can go to sesk12.org, and the information is listed there as well. All right, let's get started. I'm going to share my screen. With you. Let's minimize that. This is fourth grade science. The unit that we're on is earth science. We're looking into the Tennessee Science Standard for ESS 2.1. Before we get started, we always have a do now. So if you will, read the question with me. The diagram shown is a model of the different layers inside Earth. Which two statements best compare the crust to the rest of the layers? M, the crust surrounds all the other layers and is solid. P, the crust is the innermost layer and is liquid. R, the crust is the thinnest layer and is solid. S, the crust is the outmost layer and is liquid. T, the crust is the thickest layer and is solid. Take a moment and think about it. Read your question. Utilize the model that is shown before you to answer your question. Now, let's see what our answers should be. The diagram shown is a model of the different layers inside Earth. Now, before you is a model that has labels. One is pointing from the word crust to this section that is listed, that's shown around this diagram is the crust. You have the mantle indicating this band around it. There's the inner core, which is the shaded gray area, and the outer core, which is this white area within the model. Now, remember our test taking skills. We really have to look at the question and understand what it's asking of us. There are emphases that are placed on questions in certain ways. One way is underlining the word, and the other way is to have the word in bold print. Here, the question has two underlined words. Which two, the word two is underlined, statements best is underlined, compare the crust to the rest of the layers. What are our answers? M, the first answer, that best compares the crust to the rest of the layers. M says the crust surrounds all of the other layers and is solid. We know that to be true based off of us looking at our model. The crust surrounds all the layers, and we know the crust is solid because we know that we live on the crust of the earth. The next answer, R. The crust is the thinnest layer and is solid. Well, we've already indicated that we know the crust is to be solid, and we see that the crust is, in fact, the thinnest layer compared to the other three layers of Earth. I hope we have those answers correct. If not, let's not forget that these facts are to be true, and let's remember them for future testing. Now, here we have our lesson on earth science. Take a look at this video. Remember to take notes. Remember in this particular video that we will have vocabulary. Try to jot down information on that vocabulary, on those vocabulary words. Pause if necessary so you can jot them down because they will be used in future activities. Hello. Students explore patterns of observable phenomenon, specifically duration of day and night changes in the northern and southern hemispheres, to consider how the Earth-Sun relationship results in those observed patterns. This is day and night. Take a look at our phenomenon. Observe all details. Look at everything. Note the movement of the Earth. What do you see as the Earth is moving? Take a moment. Record your observations. What do you know about the phenomenon in this clip? Write it down. How do you think this video relates to patterns? Before we go on any further, let's talk about a few vocabulary terms. Equator, an imaginary line drawn around the Earth equally distant from both poles, dividing the Earth into northern and southern hemispheres. Northern hemisphere, the half of the Earth that is north of the equator. Take a look at our picture. What continents do you see in the northern hemisphere? Southern hemisphere, the half of Earth that is south of the equator. Please note, the Greek prefix hemi means half, and sphere means a round, solid object like a ball. So a hemisphere is half of the planet. An axis, an imaginary line an object runs around. This imaginary line runs directly through the object's center from the north to the south poles. Today, the Earth's axis is tilted 23.5 degrees from the plane of its orbit around the sun. But this tilt changes every 40,000 years. Tilt, an angle of the Earth's planet's rotation axis in relation to its orbital plane. Please look at our picture. Note the axis. The North Pole is tilted towards the sun. Rotation, the act of turning or revolving about an axis. The Earth spins on its axis, moving counterclockwise. Because of the Earth spinning counterclockwise, the sun rises in the direction of east and settles in the west. Revolution, or orbit, the path that an object takes in space when it goes around a star, a planet, or a moon. It takes Earth 365 days to make one complete revolution around the sun. Are Earth's revolutions an observable pattern? What effect does this have on our lives? Before you observe this next clip, remember, you speak what you already know. To learn, be silent, listen, and observe. Did you notice as the Earth was spinning on its tilted axis counterclockwise that one side of it experienced day, the side closest to the sun? The side farthest away from the sun experienced night. The other image shows the path or the orbit the Earth takes as it rotates around the sun. Take a look at these two data tables from a city in the Northern Hemisphere, New York City, and a city in the Southern Hemisphere, Melbourne, Australia. What do they have in common? What are the differences? Compare and contrast these two data tables and record your findings. One pattern in New York City was the daylight hours in the fall and winter months were shorter. The patterns I noticed in Melbourne, Australia, the daylight hours were shorter in the summer. Compare the data from New York City and Melbourne. What similarities do you notice? It is at this moment you should have an understanding of Earth and its relationship to the sun when creating observable patterns of day and night. Your challenge will be to recreate this model on the next slide and complete the blank areas and submit it to Ms. Earle's email box. Look forward to part 2, Earth and Universe. Take a moment and draw the model seen on your screen. Label all vocabulary terms on your model. Check your knowledge of the Earth-Sun relationship. Use the words in the box to complete the sentences. So what I want you to do is number your page 1 through 7. Use the words that are in the box to complete the sentences. Here are the answers. Number 1, axis, rotation. Number 3 is daytime. Number 4, nighttime. 5, orbit. 6, sun. Number 7, year. Take a look at this video. Now that we know about the Earth's rotation and its revolution, what relationship do those have with our seasons? Let's watch and see.
You've seen the sunset, right? And if you get up early enough, maybe you've seen it rise too. But have you ever wondered, if the sun rises every day and sets every night, where does it go when we can't see it? Well, nowhere. It's actually us that goes somewhere, because we're on the Earth and our planet is always turning or spinning on its axis. Imagine a line passing through the center of the Earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. Earth spins around on this axis like a top. This spinning movement is called the Earth's rotation, and the Earth's rotation is what gives us day and night. Every day, all year. If you're on the side of the Earth that's facing away from the sun as the Earth is spinning, it's night. If you're on the side facing the sun, it's, you guessed it, day. Now, hold on tight, because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the sun. This movement is called its revolution. One full orbit all the way around the sun is one revolution, and the Earth takes 365 days, or 1 year, to complete a revolution. So have you got all of this so far? The Earth is rotating on its axis, creating day and night, and at the same time, it's revolving all the way around the sun. Now here's the thing. As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted just a little. It's not all that much, but this tilt causes one part of the Earth to lean towards the sun, while another part of it is leaning away. This means that different parts of our planet's surface gets different amounts of sunlight and heat. So, why am I telling you all of this? Well, as the Earth travels around the sun, it creates a pattern throughout the year. This pattern happens over and over again, and I'm sure you've noticed it. At certain times of the year, you see the northern hemisphere leans towards the sun, and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the sun, and the northern hemisphere leans away. That pattern, my friend, is what makes seasons. When the part of the world that you're living in is leaning towards the sun, it's warm and the days are long. Summer. When you're on the part that's leaning away from the sun, it's cold and the days are short. Winter. In between, it's spring or autumn. If the Earth weren't tilted, we would have the same season all year long. So, revolution, rotation, orbit. Is your head spinning? Let's do a demonstration to shed a little light on these concepts. Okay, you're gonna need a globe and a table lamp without a shade, plus a table to put them both on. Put the lamp in the center of the table and turn it on. Put the globe on one side of the table. Now hit the lights. The globe is Earth. Makes sense, right? The lamp at the center of the table is the sun at the center of the solar system. Now slowly spin the globe. As the Earth rotates, the sun lights up one side of the planet better than the other. It's day where the light is shining more brightly on the globe and night where it's not. Now let's see what the Earth's revolution around the sun looks like. Give the globe a few spins with one hand while slowly pushing the globe in a circle around the sun, or the lamp, with your other hand. So, do you notice how the Earth keeps rotating as it revolves around the sun? If this were the real sun and Earth, by the time you get back to where you started, the globe would have completed 365 rotations, or days. And that's another year gone by. So, what does all this show us? It shows that what looks to us to be the motion of the sun in the sky is really caused by the motion of the Earth. So now you know, when you look up and see the sun setting or rising, it's not going around us. It's sitting pretty much at the center of the solar system, while we and the 7 other planets go around it. That sun, always gotta be the center of attention.
Okay, I know there was a lot of information in that particular video, but very, very important information to know. Now, to break down what was said in the video, Earth's seasons are caused by the tilt of the Earth's axis. If the Earth was not tilted, we would have the same season all year long. As you notice in this particular diagram, here's the axis of the Earth, and it is tilted because the Earth is tilted towards the sun. In this particular part of the year, the looks like Europe and Asia are in their summer because they're facing the sun and the Earth is tilted closer to the sun, whereas the North America and South America are experiencing winter. Here's another diagram. As you can see, each one is indicating the rotation of the Earth. So the Earth is spinning, and as it's spinning, it is in orbit. This red line represents the orbit of the sun, or the revolution of the sun. As it spins, it's spinning, and different portions of the Earth on different paths of its orbit are experiencing different seasons. Here we have North America and South America. They're closer to the sun. They're experiencing summer. In this particular location here, you have Europe and Asia and Africa experiencing their summer. Here you have, well, of course, there's summer, then there's spring and fall and winter. So it all depends on the tilt of the Earth's axis, what season each continent will be experiencing. Here's a better diagram. Here in March, the Earth axis is tilted towards the sun. So therefore, you have March, and the countries of Africa and Europe and some parts of South America are possibly experiencing spring. Here you have the summer solstice, and you have the northern hemisphere is experiencing summer. Here you have September, the sun, the Earth is tilted. So summer is between these two areas. This is winter going into spring, summer, fall, then you have winter. So in between here, this is summer and this is winter. This is spring and this is fall for us. As you can see, it just depends on what continent is closer to the Earth based off of the rotation of the axis. Here's another view. As you can see how this is tilted. So we have spring. It's March, so it's spring here. We're a little bit closer, but here we're closer to the sun. North America is closer to the sun. Exit ticket questions. Select the correct answer. Submit your answers to Ms. Earle via email. Let's check those out. So you will complete each question by choosing or typing the best answer. You'll number your answers and select the letter choice that is the best possible answer to fit the statement. Number 3, which of these examples is most likely the motion of the earth that causes day and night? You know the sun rises in the east every morning and sets in the west every evening. What is the cause? What is that causes this to happen? Allen used a flashlight at the sun and a ball as the earth. He placed the flashlight on a table. Then he held the ball, started to walk around the flashlight to show the day and the night cycle of earth. What should he do to correctly show the day and night cycle of the earth? There you have it. That is the end of our lesson. Remember to be safe, stay home, take care of yourself. Until the next time, signing off. Oh, before I go, make sure you remember to access your assignments. There are assignments under your tab. Select fourth grade Panthers. Hit the next button. You have a day and night investigation packet that you are to work. And you also have a day and night review assignment on discovery education. Check those 2 things out. Get those things back to me as soon as possible so I can see how well you have learned this particular unit. Take care of yourselves. Bye-bye.